Hello, am I audible to everyone?
Yes, sir. I can hear you.
Okay.
Okay.
Uh, uh, it is requested to please bring your laptop or desktop, which can be you used during the session.
Okay, sir. Now we should have laptop, sir. Uh,
Eh, no one.
Hello.
Is there anyone who can use his or her laptop or PC? Actually, I'm thinking I will give you some hands-on tutorial how we can use the ML in the machine learning. Like we have given to you some examples how the machine learning is used in the material science, but how can you deal with the code like Python? How can you use the Python in the same for the same purpose? So that's why I thought if it will be good if you got you get your laptop or PC.
Hello.
Huh?
Hello.
Hello, Ishwar. Huh?
Sorry, by mistake, sir. Hello. By mistake, sir.
Ah, okay. Uh, who can manage a laptop or PC? Please manage in the. We can wait for the 10 minutes more. Uh, if any one of you can get that. Hello, everyone who joined recently. It is requested to you. Please bring your PC or laptop because I am trying to give you some hand-on experience for the machine learning in the material science. Like some case studies we have discussed earlier in the session one and in the live session of the sir also. So please. It will be good for you. Maybe we will start in the 8 minute, 18:15. Okay, please uh, arrange that in during the time. Please, there will be left. There will be some internet connection also because we will use the Google Colab for this work. If any one of you have Jupyter, you can also use that. If you have some experience in that. Big one. Quiz doubt. Uh, Regarding the quiz doubt, maybe you have to. There is some question answer section. I think in the SWAM portal, you can raise the query there. Is there any other question? Please bring your laptop and PC. We will start at the 10:50. Oh, 18:15. Okay. Hello, Bhaskar and Sunil. You can get this live session on the SWIM portal. Maybe there is a some folder, some spreadsheet link, and in that link you can find the link of my YouTube channel where I have uploaded this session, or I can share the link of the YouTube channel here. Okay, okay, let's start. Uh, Maybe can you tell me who are using your PC or laptop? Can you say yes in the chat box? So, because I will keep that in mind who is using the code or not. Are you able to hear me? Or Sunil, you are using your PC or laptop. Okay. Anyone else? Maybe Ishwar is saying he will use. Or any other person? Ishwar and Sunil. Okay. Okay, let's start. Hello everyone. I'm Shivam Aggarwal, PMRFTA for the sports artificial intelligence and machine learning in the materials engineering, which is being instructed by the Professor Prashant Biswas from the Material Science and Engineering Department, IIT Kanpur. Uh, this is the third live interactive session for this course, and today we will discuss about the how we can use Python code, like how can you use the Python for the machine learning for the material science. Like we have discussed earlier, for any machine learning work, there is a five step generally. You can increase those step or decrease what the step according to your problem. Okay. For any machine learning work, there are mainly five steps. First, there is a data preparation. Like data preparation is a very crucial step for any ML work or any artificial AI because the machine will learn by using your data how it can learn about itself. So initially you have to give some data, but when we talk about in the material science also, so we have to be precise about our data, like what we want to machine learning, what it will perform, and our data should be like very uh, uh, crispy in according to that, like what we desire, what we want the desired, like what it should be learned from the data. So for that purpose, we have to look into the data very carefully. Then there is a second step, the feature engineering. Feature engineering is a very crucial step. Like just suppose you have a chemical like material, like any chemical composition. Just suppose like talk about the acids. You have the four, like for example, you have the four acid, HF, HCl, HBr or HI. Okay. Then if give you I give you the any unknown person like just HFSCL name and their properties like how they are strong to respectively to each other. Okay. So how can it will give you like HF has a very high uh, activity compared to the other, same as like what gives to that activity like high activity compared to the other. So any ML model, hello, okay. So neither any machine can get that. So we have to give some properties of its constituents like H and F, H and Cl, H and Br, H and I. So I have to give some numerical values for the F, Cl, Br, I, and H to the machine. So it can get why it is giving the higher activity compared to the each one, like respectively. So we have to give some features about the constituents to get the which can relate to the property. I can give the many features. If I talk about the chemical composition, there are the various fundamental features of the constituent elements. You have atomic number, atomic mass, number of electrons, number of protons, number of neutrons, and like their electronegativity, electron affinity, their density, radius. There are lots of properties which can you use, but you have to choose which can correlate to your output property. Third one is the model selection. Model selection is also very crucial part for an ML because your ML work is largely depend on the model, which model you are going to use for the ML. For your prediction. So for that purpose, you have to choose the model. Like there are the different kind of models, and that depends on your that largely depend on your data set. What you want to do also. Maybe there will be the different type of problems like classification, regression, and there are the many other kind of problem also. And the model evaluation. What is the evaluation? You select the model, you train the model, but you have to get evaluate that. Na? What is the high performing model among the all other model, and what is the plus point of that model, what is the negative point of that model. So you have to evaluate that. There are the different evaluation parameters that also depend on the uh, which kind of work you want to do. If you are going to use any regression problem, so you will use the R2, R2 score, RMSC, root mean square error, and MAE, mean absolute error. But in the other hand, if you are going for the classification problem, you have to choose F1 score. So these are the different kind of evaluation matrices which you will use. Then there is a fifth, prediction. That's the main part because why you are making the ML model? You want a prediction, which is thing you don't know. In your data set that is not here, there in your your first data. So you have to try to predict that. And you can also say there in the fifth, in the prediction, there should be the analysis. You can get the insights from the data, which properties are enhancing your output property, which properties are decreasing your output property, and which properties have the any there will be in material science, if you see, there is a threshold value of any property which depend on the certain input properties also. So you can get that insight from the uh, that ML1. Okay. So now we will start about the how we can use in practical application. We have used a case study in my session also, and the last which in the I think in on the Monday when sir take the session, they talk about the how they use the machine learning to uh, predict the stacking fault energy for the FCC medium entropy alloy. So we will look for this work and how they use machine learning in this, and I'll share you to the about the you can get the data from this paper also, and you can use your ML work and your code to predict this. Okay. So let's start. Medium entropy alloy is just sorry. Medium entropy alloy is a subset of the complex concentrated alloys which have the configuration entropy between the 1R to the 1.5 R. They are generally ternary or the quaternary alloys with the equiatomic composition, and they are generally exhibit the this kind of alloys the strength, the enhance the strength, ductility, and the fracture toughness of these alloys. And why this work is around about the stacking fault energy, because stacking fault energy is plays a crucial role to define the mechanism of the deformation. in the FCC medium entropy alloy. As we know, the lower SFE leads to the shift from the slip dominated plasticity to the twinning twinning needed plasticity, and which influence the strain hardening, dislocation, storage, and the some trip and trip effect in the material. So that's why stacking fault energy is a crucial parameter for a medium entropy alloy, which define the what is the mechanism of the deformation. So how can we use determine the stacking fault energy? Experimentally, it is a very it's not a very easy process uh, to determine the stacking fault energy. Like there are some experimental methods like transmission electron microscopy and the XRD, and by using this technique, we can get the idea about the stacking fault energy. But it's a very as we discussed, it's not the easy process. So before you want to the stacking fault energy, you have to synthesize that material, and then you have to do the time of of that material, and then you have to determine process that time data to calculate the stacking fault energy. Or if we use the computational technique, that also there are some computational technique which can be used to determine the stacking fault energy, like thermodynamic calculation, CalFed, and the DFT. But these process are highly rigorous, and need a very high expertise in this field to get the stacking fault energy. So in the if as we know, there is a lot of data at this time in the material science, so it is possible to use that previous data from the literature to get the trend what will be the expected stacking fault energy by using that data. So for that purpose, we can use any data driven approach, like our machine learning also is a data driven approach. We use the data from the previous literature or any calculation, so we can use that data, which get the insight from the our previous data to get the estimate from the stacking fault energy uh, for any unknown material. Okay. How can a machine use machine learning? As I discussed, it is a robust and the rapid method to predict the material property, and it is it overcomes the time and the resources constraint for the experimental and the computational method. And many of us don't have those these expert is these machines like TAM and XRD, and it needs also the high expertise in the field, and this enables the high throughput design of the medium entropy alloy, because it accelerates the designing. I just giving the composition which come in my mind, and I get the what will be the stacking fault energy from the machine learning model. If I get the a desired value for the stacking fault energy, I can try in the by that composition in the experimentally also. So it is a very good to accelerate the design, and it also can be used to get the insights from the data, like what input properties, how it correlated to the output properties. So which will also very useful for us to design new material with the desired properties. So data collection, in this work, the original data set consists of 818 data points, and this covers the ternary, quaternary, and the quinary medium entropy alloys. And this data varies have the very wide range of the stacking fault energy. Like it has a very low stacking fault energy, which is below than the 20 millijoule per meter square, to the very high, greater than the 40 millijoule per meter square. And in this data, we have we are using the 9 elements, iron, manganese, nickel, cobalt, chromium, vanadium, molybdenum, and silicon and aluminium. They are the very because we use the like a very large number of the input compositional space. So you can see, and there are the like around the 149 composition which have the very low stacking fault energy, 236 have the medium stacking fault energy, and the 433 composition have the very high stacking fault energy, which we very high means greater than the 40 millijoule, and medium means 20 to 40 millijoule, and low means below than the 20 millijoule per meter square. Like see the data which they have used. Or are you able to see my screen? So see these columns only. Okay. Here you can get the data which they used in that work. This is the Fe, Mn, nickel, cobalt, chromium, vanadium, molybdenum, silicon, aluminium, and their stacking fault energy at this temperature. Okay. Uh, and if like there are the various composition, how this shows the composition. Okay. So the composition is this is the elemental ratio. It means Fe is 6.91, magnesium is 21.98, and nickel is 5.14, and and chromium is 10.34, and vanadium is 4.64. So this composition is converted into this array. Like you can get the elemental ratio of these metals in this alloy system, medium entropy alloy. And after that, this array is converted to the other features. So primary our data set is look like this. Like I have a composition, and from that I have calculated the ratio of these elements, and it has its stacking fault energy at the corresponding temperature. Okay. Is there any question? The weight percent or at percent? It is the like elemental percentage, like it's not atomic weight. Okay. So these are our data from the starting. Then if you have a data, as I earlier discussed, so you have to convert into the features. So for the feature selection, we have used the different features like elemental content ratio, and their electronegativity is like Pauling and the Allen electronegativities, and their temperature, ionization energy, and the modulus of elasticity, atomic planar density, and the different features we have used. But as I show you the data, there are the many elements at a percent. Like if there is a 5 element at a site, uh, how did they get the SFA data? There are some experimental and some computational data. Okay. So you can unmute yourself and ask question, because I have to look into the chat. If I have not go for the chat, your question will be missed. Okay. So the feature value, like I show you, there are the many element at a site. Like I have the 5 elements, 5 metals. So I have to calculate I have the sorry, I have the, like, just suppose for example, there are the ionization energy. Okay, I have the ionization for energy for element A. I have the ionization energy for element B. I have the ionization energy of element C, and I have the ionization energy of element C, D. So there are different element and different property value. So for that purpose, if I want to use that property, so I will take the average, like the weighted average mainly. So what is the weight of that element at that site? Then what is the property value? And that is calculated by this formula. Like xi is the weight at that site, and pi is the property value of that element. And then we multiply this and make the sum for that and divide it by the what is the total element. Like what is the total weighted sum. Like for example, I will show you the data. You can get here. Here. So this is the weight x1, x2, x3, x4, x5, x6, x7, x8, x9. So you have multiplied by the ionization energy of Fe with this, ionization energy of manganese with this, ionization energy of nickel with this, ionization energy of cobalt with this, and you get the sum of this. Okay? And then you divide it by the sum of this ratio. This value. So, and you will get the average property value for this composition. And after that, yeah, I also use the variance also. So variance is similar way as we calculate the average. The variance is also calculated by using this formula. The xi pi minus p average. Pi is the property of that element minus average value and then square and multiplied by the ratio. Sorry, the value of the elemental composition. Like what is the fraction of the xi is here. Like if you use the nickel, what is the nickel ratio there? And then divided, multiplied by the property minus what is the average value of that property for that composition, and that is squared, and that is also divided by the total sum of the, like what is the sum of the elemental fraction of that composition. So now we have to look for the fourth part. Okay. So it is requested to who are using your laptop and PC, please uh, search Google Colab. Then you will get the first link. Welcome to the Colab, which is a platform of the Google to use the Python. And then you click at this new notebook. Maybe this will be empty for you. So you have to click new notebook. Then after the click on the new notebook, you get this kind of interface. Like here you will get the untitled dot ipynb, which is the extension of the Python notebook. Uh, maybe Ishwar and Sumit, I think this person are using Sunil. Okay. Is there anyone who is also using his or her PC or laptop? Ishwar, have you opened this interface?
Now only I have been, sir.
And Sunil?
Uh, I'm also using the laptop.
Okay. Okay, let's start. Uh, there are also, I'm going to share some platform. Share. Please open this website also. Okay. Okay, I have clicked the link, paste the link in the. You got the link from the chat box. I will paste the code here, and you will code that, copy that code and paste that in your Google Notebook. Okay. So let's start. I have show you the data. What is that look like? That is the it's the elemental column, and it's a stacking fault energy and the corresponding temperature at which the stacking fault energy is calculated, or uh, like it's a calculated or it's observed. Okay. So as I show you the like how the properties of this composition is calculated by using the average and the variance. So you will get the after having the properties, you will your data set will look like this. Like these are the properties, like ECR2, ECR4, ECR6, ECR8, ECR10, ECR12, and the WASP calculated LSC, and its average value and its variance, and you will get these different columns. Okay, so now start with.
What is the data set you have seen as shown by
Sorry,
ECR?
sorry, I'm
What is the data? ECR something you have shown all the E related things.
okay. ECR2 and ECR4. Actually, that is the elemental component ratio, ECR. That is calculated by the one minute. I will show you. Actually, I have not that use that. You will get from the paper. ठीक है. You will get like how they calculate the elemental component ratio. Actually, when you use the direct elemental ratio in your work, that will get some biasness about the elements. Like some elements have the high ratio, some elements have the low ratio. So it will get the like overfit or underfit our model. So for that purpose, there are some approaches which use the elemental ratio, but that use these elemental ratio in the explicit way, so it will not get like a high variance or bias to our model. So that is called the ECR, elemental component ratio, and maybe that is called have the formula like I will. My pad is working on it. You can get that from this paper. Okay. I will- Okay. You can calculate it. That ECR from this formula. XA is equal to summation of the xi to the power a, and it's the whole power is a 1 over a. What is the a? A is the number, is a like integer. Uh, this means a real number. Oh, sorry, not a real number. It's a positive integer. Like 2. Here they have used the 2, 4, 6, 8, 10, and 12 for that purpose. So it is generally shows your elemental ratio, not anything else. So now go for the
Elemental composition.
elemental composition, like nickel, cobalt. Okay, let's start. If you are using any ML work, so in the Python, so first of all, you have to load some libraries, like which will be useful for your work. Like you have to import some basic libraries like pandas, numpy, uh, So for that purpose, you have to write like import pandas as PD, or the PD. PD is just a short form for the pandas. Like if I want to use the pandas in the future code, future lines, so I have just used the PD. Same as if I import to the NumPy, generally it is a import NumPy as NP. Like if I want to use the NumPy in the future code for that any line, so I just write NP dot accord what I have to use on that. Same as matplotlib. Matplotlib is a like a plotting library. Like if you want to plot anything, so you can use the matplotlib library. sklearn uh, is a library which is generally have the some models like ML models which we used in the machine learning. It has the predefined ML models in this library, and there are some other. Yeah, there is a C1. C1 is also a like a plotting. You can get the plot from here also. There are some something is repeated. Okay. So first of all, I have to load the libraries. Maybe you get that in the code share link.
Yes, sir.
Okay, please copy and execute that. You will get you get execute this cell by enter uh, pressing the shift plus enter. Have you execute the code? Ishwar and Sunil.
Sir, I have executed, but it is not came in.
Sorry.
I have executed, sir, but it is not came in.
Okay, you have executed.
Yeah. Should I have copy the code and I have kept in,
Okay.
in
Sunil,
this Google
what
Drive.
about
Hello.
things? Okay. Then if you have to load the libraries, then you have to load the your data, like on which
I
data
have
you.
also copied, but when I press shift and enter, nothing is happening.
Sorry, I am not able to hear you actually, Master.
Will we see any result on the
No, no, no. You will not
that's what
get result from this code because it is just importing the libraries.
that's what. So we will not see any
No,
output
no, no.
yet.
You will not. Yeah, you will see like this. There is
Empty
nothing.
screen.
Yes,
So
right,
yeah,
right. Okay.
the same thing we are getting actually.
Okay. Okay. Good. Then you have to load the data. So I have load the data in the like a shared folder. So I make a link for that. Here you can see this link like for the from the Google Drive, and then you have to copy this URL and have to load by using the pandas. Like like I have to explain. So I give the URL like URL. Sorry. Are you have any question? Okay. So this is the URL, like this is the link of my folder where, oh, sorry, this is the link of the spreadsheet which I have loaded in the Google Drive, and then I load this spreadsheet by using the pandas. I have loaded the pandas as PD. PD dot read underscore CSV is used to read any CSV file.
Shivam, I have copied that and then
Sorry, one. Uh, sorry,
okay.
Bhaskar.
Yes, Shivam. I have copied that code.
Okay.
Um, I have copied that code and then I have made shift and enter, but it is not highlighting as your code.
Okay. Shift enter both are pressed together actually. Maybe.
Yes, I did it, but it's not.
Okay. Can you copy that what output you get in that code share platform or in the chat box?
I
Like,
have got like you only, sir.
sorry.
I have got the after
Now we are able to
after
see the same results as usual.
same results I have, yeah, same.
And I have.
Just a minute, let me again try it once
Can
again.
you write the chat in the chat? Actually, I am not able to
No,
clear.
we are getting the same results. The
As I have shown
Uh,
in
yeah,
the. Okay.
yeah.
Okay. And Bhaskar, please share your what you get in your Google Colab notebook.
Okay.
Uh, please don't delete anything in this code share. Otherwise, some of you will get the. Yeah. Please don't edit that, especially deleting anything, because many of you will what the problem. Bhaskar, please.
Yeah.
I don't get anything in the chat box or in the code share link. Bhaskar, you have not pasted anything. I want to what output you got in your after executing the notebook, after executing that cell, especially, so I can find out what error you are getting.
I'm not sure what is happening.
Okay, I am giving you the permission to share your screen. Okay, maybe that will be helping. Please share your screen.
Yeah.
Are you going to share your screen?
Yeah.
Please. Uh, please open your Google Notebook.
Google. What
Please
should I open?
title 0.ipn. This Google Colab tab. Please open this tab. This one untitled.ipnyb. The right one to the launch meeting.
Yeah. Yeah.
Okay, maybe you have the problem. Okay. Please uh, stop sharing. Maybe you just got something wrong. You have not pasted anything here. You have to run the code in this. First, you have to paste their code here. No, no, from not here. Like I have shared you the code share link where you was
Yes.
earlier in this
Yes.
the last one tab.
Yes.
Open this and copy this code.
Yeah.
Then paste here. Paste here in any cell that will work. Paste. Now shift plus enter.
Yeah.
Good. So you have to copy the code from the code share portal and then paste here. Okay.
Yeah.
As I write in my, as you see in the screen. Okay.
Okay.
Now please stop the sharing.
Thanks.
Okay. So,
So what are these libraries? Why we are using this?
why we are using this? Because the actual coding is too complicated. So you have to make the by default libraries to use those like just suppose if you want to like calculate something else, like you have to calculate like you have to take RMSC value, just suppose for example. Okay. So on by yourself, if you write the code for the RMSC, it will be like too big. But there are the predefined libraries in the pandas you can or in the some NumPy or in some other libraries, you can use just RMSC and you will get the output from that. That's why we use the libraries because it makes the life easier. You and me like a person work in the Python. Otherwise, it will be too complicated for us. Maybe you got your answer
Yeah, I got it.
because it's too complicated to code for everything. Because we are not just coding, we are just using the some libraries and functioning them by some brain by using some brain. Okay, after loading your data, you see your data set, maybe, okay. You see your data set like there is some elemental ratios, the properties. So if you want to see what is the columns I have in my data set, just suppose I have, your data set is a load here, df, like data frame. Data frame is equal to pd dot read underscore csv, and you have loaded your URL and get your data frame. So your data is saved virtually here as a df. If I press the df and press shift enter, I will get my what is the data frame I have using. I'm using. Are you able to see this? After writing the df and pressing the shift enter, are you getting the this output? Then if you got some other insights from this data, you can by using any, like if you want to see what are the columns here, df dot columns, you can get the like what columns are here. Like there are the columns name Fe, manganese, nickel, Co, Cr, V, Mo, and or if you want to get the size of the data set, df dot shape. Okay. By using the df dot shape, you can get the size of your data set. Like it is a 774 into 53 matrix. So I have copied. You can and paste it here. You can copy and paste. And there is some code which is df. And there is a df dot once. Are you able to do this?
Yes, sir.
Okay. Everyone, na? Is there anyone who is get any problem? Maybe you have not got any problem because it is simple, but many of you are not from this background, so they got problem. Okay. After loading your data, so what you want to do about your data? Because you are here to get train that data in your with your output properties. Like there is a like your input property is just if in the mathematics we use like input properties as x and output properties as y. So we just tell our ML model. So I have to define what is the input properties and what is the output properties. So for that purpose, I have to give the code here as what is the x and what is the y here. So I have to separate that. So for that purpose, I'm using this code and I have pasted here also. It is the just see. First, I define what columns have to drop because here you can see there is a elemental ratio here and this is the elemental ratio here also. ECR2, ECR4, ECR6, ECR8, which is also contain the same information about the elemental ratio. So I have to remove one of this. So I have earlier discussed like ECR is more reliable than the elemental ratio. So I have to remove this. So I define columns to drop and write the name of these columns. And then I just drop from the DF and other columns like I just drop this and this SFP because it is our Y and these other columns will be used as a X and it's defined by using this X is equal to DF. DF means DF our name of the data set. DF dot drop columns which have to be dropped and then Y is equal to DF only SFP. SFP is our only Y. So I just check and press shift enter. Now if you want to see it is working or not, so you can get a H head to see what is our X. So you can see here and compare from this DF, FV, MN, NI, CU, CRV are got removed from here. So if I just want to see the columns X dot sorry. Are you able to define the X and Y? Bhaskar? Anyone have any problem till now? Bhaskar, Arun?
It is working fine.
Okay, it's working fine. Okay, great. We have defined X and Y. Okay, but here, as we discussed in this, so we have to, we have
Can I ask one question?
please.
That X dot columns we are searching,
Hmm.
then why it is showing all these columns? We have selected only few.
Because we have dropped them. We have not define X to the that column. We have dropped those column from the DF. DF dot drop you use na.
Ah,
So you drop those columns which you define there. Columns to drop. So this is not a
no,
one.
but we are saving those specific 5 to 6 columns in the X.
No, we have not saved those. We just draw. These okay. Just think. Y, I have write a code for the Y is equal to DF SFE. Is just take the DF SFE from the DF as a Y. You can see here Y. Okay. Y is equal to SFE only. Okay.
Okay.
If I want to take just this column, I don't write about the drop. Drop is used to drop this column's name
Okay.
and from the DF.
Okay. Okay.
Maybe you got your answer, I think.
Yeah. Yeah. Yeah.
Okay. If you some problem, there is another code. Actually, in that we use the DF and like there's a uh, square column and write those square bracket and write this column name and we'll define them. Okay. Now, okay. I have the like that. You can also check the size of your before looking for this. Maybe I have to check the size of the X because I want to know what is the you can see there is a 43 columns as a X. Okay. So there is a large number of properties. So I have to constrain myself or constrain to any ML model to reduce its dimensionality. Because if there are dimension there is an input property, input variables is increasing, your models get a very complex model, and it will lead to the some undertraining or undertraining on the overtrain in the training time. So that's why we have to generally reduce our dimension of the input variables. So for that purpose, we use some engineering, which is called the feature engineering. So in the feature engineering, there are the some methods which are generally used to get the reduced dimension. But in this work, Swadhyay and others use three-step hybrid feature selection. What they have done? First, they use the wrapper forward selection. Why they use this? This mode, this selection actually reduce the input size from 44 to 10. They reduce the dimensions from the 44 to 10. After that, what is the those 10 features? They have used the paper. In the PPT also have that. Okay. They use only these properties: temperature, ACR4, and the VASP, GGA, LSC variance, SGT, LSC variance. How they calculated? Actually, these uh, these features have the the low correlation in between them. Because what is the correlation between them? Like just suppose you have the two properties, okay, and those properties giving the same information to me. Like if one is increasing, another is also increasing in the same ratio. If one is decreasing, another one is decreasing the same ratio. So what will give the output to your model? Because they have the same thing. Maybe you are able to understand me. Do you have any question in this regards? The correlation. Okay. Just the
I have not understand.
sorry.
I have not understand.
Okay. Just suppose there are the two variables in the input data set. So there are the two features which have give the same information. Okay. Like just suppose one feature is directly correlated to the second one. And they have like just suppose maybe I'm not able to write today. Okay. If I have a two properties like x1 and x2, okay, and x2 is just some constant multiplied by 2x2, okay, then if I make any model feature by using x1 and x2, then they will give the same information na, to my model. Like x1 is x1, but sorry, x2 is x2, but x1 is also kx1, x2. So these two features provide the same information to my model. Why? Because if you do any statistics, they will that will rely on the process f is equal to sorry y is equal to f x1 x2 x3 and so on, and x1 x1 is equal to the kx2 and this is x2. So there is a no point to using the two maybe I'm not sound good. I think in this way, maybe I will show you to in the better way, so it will be understandable to you in the next session. Maybe okay. Maybe I'm not sound good here. So there first, now you just thought we have to reduce the dimensionality. Why? Because if your input features have the high correlation in between them, they will provide the same information to our model. And by using the different features which have the same kind of things provided to our model, then they will lead to the overfitting to our model. That will lead to the overfitting to the model, and as well as they will lead to the not generalization. There will not be a generalization in our model. So we have to remove those features. Okay. So for that purpose, they have used wrapper forward selection, and by using the wrapper forward selection, they reduce the size of this data set to the only just 44 to 10. And after getting these 10 features, and they got these 10 features like temperature, ECR4, and heat of fusion average, you can get from the paper. And they have plotted these correlation matrix. These are the correlation matrix which shows the correlation between these features. You can get here this is the 0.75 positive correlation. Sorry, this is the negative correlation, and this is the positive correlation. And if you see these three features have a correlation, very high negative correlation. If you see these three features have a good positive correlation. Are you able to see? Now, if I want to plot the, this is called the heat map, and this is called the correlation matrix. Oh, sorry, this is the heat map which is plotted by using the correlation matrix. What is the correlation matrix? It is the correlation between the uh, two properties, two input features, and which is calculated by using this formula. Rxy is equal to xi minus x bar and yi minus y bar, and you can get this from the PPT. I will share to you. Now, if I want to calculate the correlation matrix, and so I'm not showing here how to use the wrapper forward method. Now, I just select these features which have high, which they have used in the final model. Like these are the 10 features which are used to plot the correlation matrix. So this is the x is equal to. So you can see who asked me the question about the drop. So you can see if I select only some column, so then I have to just write the name of those column and enclosed in between the square bracket, and just write the from which they have using those columns. So x is equal to x, the selected column, and just press shift enter. I just, now you can see there are the just 10 columns in the x. please copy this code and paste this. Okay. As you get your X and as you get your Y, so for any model, you have to restrict your input values to a certain range. Just suppose I have a, okay, you can see the range of the code. Like the temperature varies from 300 to 1000. If you see the ECR4 varies from the 47, 55, 35, 29. So I can just get, say roughly it is varying from 29 to 50. If I see the LSC variance, it is varying from the 1920 to 45 also. So it is a very high range. It is a very short range. So as your input have the various ranges. So if you train your model, as you know, your model is like just to train by using these values x and y, x1, y, x2, x3, x4. So in that purpose, by you having this high range of the input properties, value of the input properties, that will not lead to the your like a maximum point. Here that should be the converse, like it is not lead to the converse point. So for that purpose, we have to restrict the range of the input variables to a particular value, like in the same range, just ideally. So for that purpose, there are the various approach which used to normalize the values of our input data set, in which there is a one approach which is called min-max scalar. What this done? What this thing do? Actually, these things do like the minimum. What is the minimum value of that input? That will lead to the zero, and what will the maximum? That will lead to the one, and the in between values will be scaled according to that. Like here is the formula. You can see y dash is equal to a plus b minus a, y minus y minimum divided by y maximum minus y minimum. What is the b and a? B and a is the maximum, and what would be the maximum and the minimum value we want to give. Like for this work, we have give a is equal to 0, sorry, small. A is equal to 0 and b is equal to 1. So I have to normalize the all over value between 0 to 1. Okay. So if it have the minimum value, it will be the 0, and it is the have the maximum value, it will be the 1, and all the values between them will be scaled according to that. This is just a normalization process. Okay. And it will normalize all the values, all the input variables. So because I have, so for that purpose, I use min-max scalar pre-processing dot min-max scalar. So I have import this, sorry, here from sklearn import pre-processing. Then I, sorry, then I scaled x by using the min-max scalar dot fit and transform x. I define x here. So x will be transformed and defined. So x normalized is equal to pd dot data frame x scaled. So I have to save this scaled value now. So that's why I make a data frame by using the x pd dot data frame x scaled. What is the name? So you can copy and paste it and execute this in your Google Colab notebook. Sorry. So now we can see what is our the now x. So x normalized. So now you can see it's between the like everything is below than the one. Like below, like in the between 0 and 1. What is this? Okay. Just suppose if you want to see the 50 columns, sorry, 50 rows in the X. So you will write the like 50, 10 here. So you will get number of the columns here. Are you able to do this?
I have not nothing for a minimum max scalar that
Actually, there will
for
be no
that code.
output. There will be no output for the min max scalar. So as you can see, I have not get any output, but you can see here there is a green tick. If you have a green tick, your code is executed. Like just suppose I have make any mistake, so you will get what is the uh, just suppose I write y dot shape. Okay, it will not show anything. Sorry, y dot sorry. So here you can see there is a red sign. So that is showing there is some error. Otherwise, it is got executed if you got a green tick. So if I run now, I will get a green tick here. So my code is executed. Okay. Now please have a look into the x normalized dot head. So you can get your values are got scaled or not. Now we plot the correlation matrix also uh, to see what's the correlation between our input. Have you got this output for the correlation matrix? Everyone got the correlation matrix plot? Anyone who is not able? Arun? Sunil? Uh, Ishwar?
Yes, sir. Yes.
Have you got it the plot?
I've got it for this.
Okay. Bhaskar got it, Muskan got it. Okay. Oh, okay. Now see what this plot shows. You can see here there is a some number. Okay. What is the number show? This number generally shows the correlation between the these properties. Like here you can see these are temperature row, uh, and this is the columns with the temperature ECR4, this value like LSC variance, LSC average. So here you can see this is the correlation between temperature and ECR4. So what is the value is the point, sorry, minus 0.73. So if they have the correlation between them is the negative correlation, but it is a very high correlation, not very high, it is a high correlation like 0.73, like point, because your correlation value generally, this is called the Pearson correlation coefficient. PCC value generally varies from the -1 to +1. -1, it is a like highly negative correlated. Positive one means highly positive correlation. So these are like 0.73. These are like a high negative correlation, but it's not a too high. Actually, just if generally in the machine learning practices, if we got the correlation value, absolute correlation value between larger than the 0.95 or zero point 0.9, they are called the highly correlated factors. Or generally, we got removed one of them. Like if your two values input properties have the correlation larger than the 0.95, so I have to remove one of them, not both, because they are giving the same question both, but one have to be there, na? So that's why we remove one from them. Many cases we found like there are the three properties. They have we have the highly correlated factor, high correlation factor in between them. So we have removed uh, uh, all of them, just take one from them. Like just suppose there are the 5 factors which are highly correlated. So I remove 4 and take 1 for further processing. So here correlation in this heat map, you can find there are not a very high correlation like just says 0.95 greater than 0.95. So here you can see there is a correlation between the total electron variance and the electronegativity average is about 0.95. So there is still some high correlation. Ln electronegativity between electron variance, these are 0.95. So these are both same. Okay, sorry. Or there are any other, if you found anything which is highly correlated or highly negative correlated, 0.93, 0.93. So if I see there is a one property generally, so I can remove it manually. So I can take like a 0.95, 0.95. These from these two correlate these two properties, I have to remove one. Otherwise, I have implement any other method to remove this. So for that purpose, in this work, they have used some other methods, which is a gradient boosting technique. What they have done, they use this method to reduce 10 to 7 features. Like they have reduced 3 more features from them. How? They evaluate they train the model and they got the values, and after that they remove the 3 feature which does not show the any high correlation value. So here is the plot they have used. So here you can see the specific heat average shows the very high importance factor in the output properties. Ionization energy average have a some importance factor. SG-LSC variance have some, but after this, there are the 3 properties also which can you find here. They are removed just because they are not contributing too much into the output property. Now there will be a question, how you get this value, like this importance factor. So for that purpose, they choose these 10 variables, these 10 properties. Then by using this 10 input feature, they have trained gradient boost model various times and got that the importance factor, because any model you from the any model you can get the importance factor. Like how the output property is related to the any input properties for that model. So that is called the importance factor, like how it depend on the input value. So for that purpose, they have calculated for that, and they have do this multiple times, and they got the average value for that, and use and get that and upload that and find there are the three properties which are not contributing more, so they have removed them. So here you can easily see so that's why this correlation matrix is generally used to see the correlation between the input features. Now, after the I have got the final output properties, what will be the x and y for my future uh, purpose, like future, like in the for the model selection and the model, like we have used the two-step done, like data set and feature engineering. Now we have to move on to the model, how we can use any ML model. So in this work, generally they have used the linear regression, lasso regression, and GBR, gradient boost regression, and random forest. So we have to use, we can check that. So there is a, okay, before applying any model, any ML model, we have to split our data set into two parts, generally two parts. You can split that data set into the many part, but generally we have to split that data set into the two parts, train and test. What is the train test? So train data is used to train your model. Like if you have a 100 data point, you have used the 80 points to train your model, and then you check your model onto those 20 points. If they are predicted, uh, like they have predicted the value for those 20 points is around their actual value or not. Why you use that 20 points separately? Because in this 80 point, you have used your model to train. So your model know about those 80 points. So if that predict, that will be close to their exact value, like their actual value. So there is a no point to predict like the get the evaluation score for those training points. So that's why we keep our separate data set, that is called the test data set. Okay. Sometimes you can also tune your test data set, like I have choose that 10 20 point, that is not that will give the approx values for your or exact like actual value. Predicted value will be the close to the actual value. So for that purpose, we use the different cross validation. Like sometimes, like just suppose. Okay. For that purpose, we have split it into our data set into the few parts. Just suppose I have split it out my data into the 10 parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. In 10 parts. Okay. Then what I will do, I will use this data set as a training, sorry, this data set as a testing, and this as a, or just one. Okay. Just one. And this all will be used for the testing purpose. This will be test and this will be train. Yeah, it means from the 10, 9 will be used, 10 parts are used to train the model, and one is used for the test the model. Then test will be changed. Now this and this will be used for train. This is also train. And now this part will be used for test. In this way, every part will be used for the test and every part will be used for the train, and this model will run for the 10 times, and after that we will got the evaluation average evaluation matrices. that will would be the more exact value, like because in that value there will be not biasing anything, because for my I'm if I'm working I can bias the test set also, no? So that's why we use this kind of methods to ensure that there our model is not biasing, we are not biasing. So this is called a k-fold cross validation, because the here k is equal to 10 I choose, and it is called k-fold cross validation. But it will be like we do this in the last. First, we just take 20-80% and use in our model to train the data set. So first, I have split it about my data set by using the sklearn model selection train test split. Maybe I have pasted there. Okay, I have not pasted. Guys, this is not working. Oh, sorry. Reconnecting. Maybe I not a good connection. I am pasting that in the chat box. Please copy from there. Okay, okay. Okay, I have pasted here also. I split in my data set. Here you can see I have load this train test split from the sklearn.model selection, which is the predefined library, and then I make x train, x test, y train, y test, by 10 test split. What is the x? X normalized, which I defined earlier, which is the min max scalar standard normalized data, and corresponding y values, and the random state zero. What is the random state? Actually, random state is defined like here you can see this is splitting our data set into the two part, but from where it is going to split, like from the starting, it can split that data set from anywhere. It is not a, just a like organized thing. So if I'm not giving any random state, for that purpose, every time I execute this code, it will take new set for the X or train or N test. So for that purpose, I'm getting the same test and same train data every time. So we have to keep this value fixed. Like sometimes people are use 42, sometimes they have used 11. Sometimes you can choose any value, but that will be fixed during your work. Otherwise, you will get the like get a different values in the when you train the model. Okay, and test size. So it defines the ratio. Like I am splitting into the 80-20 part. So it is the 0.2 fraction. What is the fraction of the test size? So then execute this. Now you get your X train and X. So now you can, if you want to see, this is your X train. This is your phi train. So here you can see these are thing. This is a 231 column row. These are 231 row. These are row number 71. This is corresponding to row number 71. So everything is perfect, because uh, for the same value they have to be the same, like X and Y. Please copy this code and execute this. Same you can do for the X test, sorry, Y test. All of you execute with this code, or anyone not able to do this? So now we are going for the model. Sorry. So when you are trying to load any model, so first of all you have to define that. So I have defined for the I'm a load for the linear regression. So I load that model. Model, I give the name model is equal to linear regression. Then these have to be fit. So model dot fit. किसको fit करना था मैं? What we have to fit? X train and Y train na. As we have split our data set into two part, train and test. So we have to train our train data set. So linear regression model have to be fitted on to the X train and Y train. So we run this. So our model is got trained. After the training the value, what we have to do? This is getting trained. So model is getting trained. So we have to now execute this model onto the test data set or into the trained data set also, and then get what will be the prediction value we got. And after getting the prediction, I'm also want to look for the how it varying from the actual value. So for that purpose, what I will do, I will make the prediction like Y train prediction will be the model dot predict. Here you can see model dot fit is used for the fitting. Model dot predict will be used for the prediction. What have to be predict? X train, only X set, not a Y. What have to be predict? X test. So I will predict for the train data set also, for the test data set also. So and those prediction will be saved into the Y test pred and Y train pred. Please copy this code and execute in your Google Notebook.
Means it will be in upper model linear regression you have given the code, right? In that code it will be prediction values will be registered.
Ishwar, I'm not able to hear you actually. Can you please say it loud?
Here now you have created a linear regression table, right? Somewhat you have created. In that table, it will be the predicted will be predicted value we get now. It have same it have predicted, right, some values.
So you want to the second code. This is the trade.
No. What is the user of the upper code?
What is the use of the upper code? This one.
Yeah. The linear regression and model fit that one.
So in this code, I define my model. Model will equal to the linear regression. Like as I say the model, it will execute the linear regression. Then model dot fit. It model linear regression. It means linear regression is fitting in X train and Y train. Now it is using the X and it is using the Y, and it is going to fitting in such a way in the just suppose uh, maybe sir will discuss about in the detail. Let's just suppose when we work in the linear regression, what is the linear regression? Just y is equal to ax1 plus by, sorry, x2 in the same way. Maybe you know about this. You know about this. Like y will be the function of the x1, x2, x3, and xn.
Yeah.
Okay. So if you want to like different, you have the different x, y, and x. Like this is the 1, 1, 1, 1, and this is your y2, same as. Then there is a y3, there is a y4, and you have a complete data set. So you don't know about the values of the a, b, and n. You know about the value of y1, y2, y3, and you know about the value of the x1, x2, x3 for the every y1, y2, y3 corresponding. Hai Then you want to choose the value of the a, b, this coefficients. For the to know about the this coefficient, you have to using the different algorithm. Like just suppose maybe many of you have used the numerical methods to solve the any problem like this. X is equal to uh, uh, y is equal to 2x plus 3y. Uh,
Can you say in that matter what is y, what is x? Can you say
what
in
is the XY? What is
means
no?
real example? Can you say in whether what is that what is the data whether y is what is x and why we should imagine the
You
a
you can think about this like it is just a fitting kind of like you have a plot x and y. Okay. And you don't know you have a points like this. For every x you have a y. So you don't know what will be the value of the what will be the coefficient for this. Like just x is y is equal to mx. You don't know about the value of m. So for that you have tried to the different values. You will go for the this, then solve according to this, then this point, at this point, then at this point, and then you will learn about this like oh, there is the value of some is same value. I will put here, and I will get the every value for the y. Maybe oh, just I have an example. I think just for sake of simplicity, you have a y1 is equal to ax1 a1x1 plus b1 x2. Okay. And then here you have a y2 is equal to a2 x1. This is not a square, just as the 2. b2. Now you have a y values, you have a x1 x2 values, you have a these values. You don't know about the coefficients. This. Now you take the example is they about this like 3 is equal to 5a1 plus 6b1. Now 4 is equal to this also be 1 a1 b1. Okay. 3a1 plus 5b1. Now you have to solve this fitting. So for that purpose, you have to choose like take this value and arbitrarily choose the value of a1 and b1. Then you will go for to the check the error. What is the error? Then you will try to minimize the error. According to that, you will get the a1 and value and b1 value. So then you can arbitrarily put the values of the x and you will get the value of your y. That's the purpose here. So in the fitting value, you give the model about the y, about the x. Sorry, this is x. About the x. And it will try to get the values of a1, b1 and any other things. I'm just telling about this a linear relation. Maybe you got your answer, I think, now.
Okay. Now,
Okay.
the graph will given this a1, b1 values, the coefficients of that
Coefficient.
actual.
I'm just telling about the linear. It's not as same as this.
Not,
You
okay.
can get from here. Now, in the prediction part, you just giving this x1, x2, x3, and now you that model using the a1, b1 values from the previous experience, like fitting experience, and that will use the values of the a1, a2 values, and now that will give you to the y in the prediction. When you write about model, what have to be predict? X train or X test. Maybe I clear now? Okay. Now let's go back into the model. So here we got we fit the model. Now we predict the model. Get the prediction from the model. But what we'll do about the do from the prediction? We have to evaluate like how it varying from the actual values. So for that, I have to choose the different correlation or different matrices, evaluation matrices. So for that purpose, I am using the R2 score, which is defined as the R2 score, Y train and Y train prediction. So it is getting it is going to get the R2 score between the Y train and Y train prediction. Whatever the model gives here. Same as it will do for the test set also. So we can execute this together. Mean squared values were defined. Okay, got it. So we have not defined previously R2 score, mean squared error, and the mean absolute error. So we have to give to the code because this is the predefined in our library sklearn matrices. So I import these matrices from there. Please copy this code and paste. I have not discussed about the evaluation matrices. So you can see here what is the evaluation matrices. After like after executing the models, we have to go for the evaluation of our model. So these are the some evaluation matrices like R2 score, mean absolute error, root mean square error, and maybe mean absolute error. Maybe all of you know about this. This is the xi, the uh, the predicted value, and xi cap is the predicted value, and it will get the difference between them and for every x values, and then it divided by the total number, like it's the average of for the all predictions. And this is the RMSE, this is the root mean square error. So here is the it takes the difference between the predicted value and the actual value, then it square for that, and then it is divided by the total number of like how many prediction are happened, and then it's divided by that value, that n, and then we get the sum, and after that we got the, sorry, there is a, sorry, this is the actual number, the sum of the all the squares, and this is divided by the total number of how many prediction it makes, and then it's got root of that, square root of that. And what is the R2 score? R2 score is just is a matrix which is widely used to get the to evaluate the any ML model. What is the R2 score? If R2 score is a 1, then it is going to the sorry, for any ML model, ideally R2 score should be 1. But one if R2 score is a 1, it also shows that it is going to overfit our model. But if I am getting the for the train and test, both will be the 1. So our model is working fine, close to the 1, not 1. Here, as you keep, we are not show the our different model first. So I have to look for the evaluation matrix. We have make a code. Now I want to get those values. So I have to print all of them. So you can see here R2 score is a 0.5080 for the training data set. And for the testing data set is a 0.61. And mean absolute error is a 21. And if you see these evaluation metrics are the close to each other, so I am not getting the, are you able to see this? Have you run this code? Bhaskar and Ishwar? Mastan, have you got the result? Please run this.
Yes, sir. I got the details, sir.
Okay, you got the results for the
Yes.
artist. Okay. Maybe you got the same result, I think. Please check these values.
No, I have got something. Training data evaluation. Same you have what you got like that.
Maybe some difference, but around same.
Yes, sir. Some change, sir, in the result.
Okay, that should be expected because it's a ML. It is just a statistical technique. So I'm getting the different result. You will get the different result. That is happening due to this because you have used the random state 0, and I'm using the random state 42. If I change this, maybe we got the same result. Now we are getting the same results or not?
Yeah, it is same.
Now it is the same now. So that's why random state is important factor here. If I am not placing the random state any value, just check this. I am not giving it to the any value. Just check this. R2 score is 0.56 and it is a 0.39.
Same.
1 minute. Okay, it's not executed well. That's all I'm saying. Now, it's not same.
Yes.
This
No,
change.
it's changed.
And I have not given any value, and I run this code again.
Why random that one
Now
place state is
it is changed again. That's why you have to fix the random state value. Sometimes in the machine learning models, people see this value in the starting, like seed is equal to 42, and everywhere it comes the random state that is equal to the seed. So that will be fixed from the starting. So till now we have learned about the how we have to go till the model state, like to execute the model. Okay. So there are the different parameters also, like some plotting, how we get the plot from the machine learning, how we can go get the plot in the uh, for like a different. We have to show you the PPT, like this kind of plot. Here you can see there is a R2 score plot for the different models like linear regression, lasso regression, GBR, KNR, and here you can see MLPNN gives the highest value. This is for the test set, not for the training set. So we can say MLPN is the working good, and we can go for this model for our prediction part. So here in this work they have used the different feature value also, like they have removed other features also from the last. From this table, like I just removed the ECR4, C dash variance for getting the 4 parameters. So they have done this. And after using these work, they find MLPNN is a very good working good with 7 parameters. And after that, these are some key findings from their work, like sorry, they have find MLPNN is a working good. There is a something hyperparameter. We have not discussed yet, but in the future classes, I will discuss about this. I'm just saying like the hyperparameter. Hyperparameter is the parameters of the models. Like models have the different parameters also. So we can tune those parameters to tune our model also. Like just suppose I'm working on the same model, like just suppose linear regression. No, or not a linear regression. Just working with the GBR, gradient boost regression. So in the gradient boost regression, there are the different parameters like n estimators, number of trees, and split size. They are the different things. So I can use those and I can tune those and got the different like the higher accuracy or the lower accuracy. So that is a part of the tuning. So that is called the hyperparameter tuning. So for that there are different kind of algos which can be used like random search, and there is a grid search, then there is a GA search, genetic algorithm. So after that, they have found the MLPNN shows the very good value, and with the R2 score for the training set is the 0.87, and the and for the R2 score for the test set is the 0.85, which is the quite comparable. And here you can see these is the predicted value and these are reported value, actual value. And you got the same values for them, like the 50 is also showing the 50. If the reported values are 200, it is approximately 200. And this is the RMSC value for the average RMSC value for this points. For the test set is 16.14, and for the train set is 15.10. And these pink points show the testing set, and the blue one shows the training set. And here is the R2 score and the RMSC, how it is get decrease and increase in the R2 score as we increase the and decrease the 10 test split set. Like just suppose we have take the 0.2, If I take the 0.3, it means the 30% is the test set and 70% is the training set. If I choose the 0.4, then it will be the 0.4 test set 40% and the train will be the 60%. So here you can see how the RMSE or R2 score get increase and decrease. So R2 score have to be increased as the test is that is decreasing. And the sharp analysis, maybe many of you have not heard about this in the machine learning. Actually, machine learning models are the quite black box model. So you can't get that how which property is more determining like more crucial in this, and they have the positive correlation with the property and they have the negative correlation with the property. For that purpose, the sharp analysis is generally nowadays are going to be popular. And in this model, we have just have got a different plot like which are based on the sharp value. Sharp value is mainly based on the game theory thing. And here you can see the specific heat average shows the plus 25.84, which is the mean sharp value for this property to the your in output property. And here you can see this the how it is varying. You can see there is a positive correlation, like your feature value is high, then your output value is high. So you can see there is a positive correlation. But if you see the ionization energy average, here you can see the negative correlation. Why? As your feature value is decreased, like is increasing, like yellow to red, then you can see here your output value is getting decreased. So that's why it is saying that there is a negative correlation in between the ionization energy average and your SFE. And in this plot, you can get those in detail. This is the predicted and reported value which they compare, and they get approximately same, and they have calculated this. There is some error about like 20% or 25%, which is acceptable. And this is the some they plot like how they get the SFE value if they make a ternary compound, like chromium percentage, cobalt percentage, and the nickel atomic percentage. If I got at this point, how I get the stacking fault energy? Sorry.
అనే అది తింటుంది కదా దాంట్లో నెరిపోడి కాలుస్తున్నారు నెరిపోడి ఫేస్ స్మైల్ లేకపోతే మాట్లాడు.
So they plotted this and got the value according to that. And you can select your resign from this plot. So where you have to work, like if you want a stacking fault energy around the 60, and if I talk about the nickel, manganese, iron, so there is this region and this region where I can got that is stacking fault energy. So I can choose that. So that's in this way we can accelerate our discovery, metal discovery with the targeted properties. So these are some results. Like they got the very good R2 score value 0.85 for the train test set, and there is a identified the some stacking for like some features which highly influence the stacking fault energy, and they also get a like a empirical formula kind of for the stacking fault energy by using these input properties. And they got the enable to quick SFE prediction by to identify the low SFE energy for activating the any phenomena which they required without experimental testing. Thank you so much for hearing me. If you have any question, please feel free to ask.
You have said about gradient boosting technique, right? You have shown that graph. In that graph, you have said that you have decreased some. You have decreased some parameters because of correlation. But in the y-axis, you have a future importance score. You have said, right?
Oh, okay, in this plot, na, I think.
And that plot only. But
Okay.
what the parameter, what the means you negative correlations you have deleted it. How you have deleted that negative correlations?
Actually, this is not so you are asking in me about in this plot. Maybe
Yeah.
In this. In
Yeah,
this plot.
yeah. That
Okay.
gradient boosting technology, that plot.
The gradient movement. So this is a feature importance score is actually is not about the correlation factors. It is the independent feature which is generally get to us into the our model, into the training models. Like just you are using the random forest. Just suppose here they are using the gradient boost regressor. Just suppose you are using the random forest. So you have trained that model. You have predicted that model. Then there is a there is a attribute there also. You can get the feature importance score. What the feature importance score? Actually, in the training, in the from the training part, that model gives us the which parameters highly influence the output properties. Just suppose I have writing this. Just suppose, yes, sir. Y1 is equal to A1, X1, B1, X2. Just suppose A1 values is a quite high, bigger than the B1. Then the A1 is the giving the like X1 is the highly correlated to it. It means to the Y1,
The
or I can
predicted
say,
value you are saying, to the predicted values.
sorry.
It is higher means whether it is predicting exactly you are saying like that.
So it is a highly influenced to the my predicted value, prediction value compared to the B1. Like just suppose, just want to give the example.
Yeah, I have understand. Like that they in that graph only that parameter is that parameter the specific heat parameter is exactly predicted value they are matching like that.
Sorry, I'm not able to hear them. Value.
No. That the specific heat parameter is there, right? That
Yeah.
parameter is predicted value and the actual value is matching very well. You are saying that.
No, it's not a matching variable. It's the input property. It's not a Y thing. There's the X1. There's the X values. So this is showing that you're determining the Y. It means SFV. In determining the SFV, value of the specific heat average is playing the crucial role. Like it is a highly influential to the output property. That's why it is a given.
Okay. Oh, okay.
Maybe now I'm clear to you.
Yeah. For SFP, it is playing a
SFA is
role.
largely depending
Specific
on the
heat is playing a
application
crucial
also.
role.
But it is largely depending on the specific heat. Here you can also see in the this one. Here I also got the same result. The value of the specific heat value is playing crucially to define to predict our SFP value. This is the average value for the SFP is largely depend on the specific heat average.
Okay.
Okay, maybe it is clear to you now.
Yeah.
Any other question?
But I am not getting very well, but future classes I can understand. I think so.
Okay, maybe you will hear about this. And from now we will doing the session in this way. I will discuss some training about the machine learning, how you can execute that by using the example from the literature. Okay. So you
Can we
can
save this this Google Colab thing?
which I have right.
No, we have run the code and we have run right in Google Colab. We
Yeah,
can save that thing.
that is saved in your Google Drive also.
Okay.
You can see what the Google account you are using at this time, and that will be in your Google Drive.
Okay.
You can name this file, so you can find easily. That's why I'm using the Google Colab. That will be easy to use without any installing anything. Is there any question about the coding part also?
Coding part, let me, we can understand that codes means that.
First, we will go through that, and you will like you can also see the GitHub link in this paper. So that will be also that clear to you, I think.
Okay.
Okay. Thank you so much. Any other question? Bhaskar, Mastan, Lavanya. Okay. Okay. Thank you so much. So I'm going to end up this.
Excuse me, sir, one thing. Try to give the summary of this session, by that we can finalize that, transcript that full of the notes like that.
Sorry.
Not video. It will be given AI, something AI will giving some summary like that. All question will make for this session.
But you want to like some like transcript for this session.
Yeah.
Maybe you would not get that.
Okay.
This, live, you can find this on the like YouTube.
Yeah, we can get, but knowing that thing means we can note that one point like that. We have listened all files, right? Like that.
Okay, you have you have any question, you can like comment on the link, or you can ask me in the next session. I will give you the answer according to.
Okay. Okay.
But
Okay.
you will not get any transcript for this session because who's maybe I think transcript will be shared to about the sir's class, I think.
Okay.
Okay.
Okay. No. Okay. Thank you.
Yeah, you can ask me any time, like in any class, and or any in the comment box or in the question answer also on the NPTEL.
Okay. 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 Thank you.
Thank you so much. Thanks to all of you. Bye bye.